Oh, let's remember logarithms over snacks. Anyway, so when we have a log equation or an expression or a function, whatever we're doing, solving, evaluating, graphing, you know how it sounds. BAP. The base here is 8. The power is 2. Okay, equal to the answer. Base, answer, power. 8 squared, we know it's 64. We're on the quest for x forever. We're going to move that 11. You know how to move it to the other side. We undo subtraction with addition. 75 is triple a prize. You undo 3. Reverse multiplication with division. What's your prize? 25. Can you keep it? Does it keep the argument positive? You bet your books it does. If you plug that 25 back in, this argument stays positive. All is well. A base to a power stays positive. Okay, well, I know you want more, so here you go. If we've got a log equation that involves the sum of 2 logs, we want to shrink it down to 1 log. Since they're added, we will multiply. Or, since they're positive, we'll just keep them up in the numerator. Now, we didn't show you a base. I know. You know what that base is. If you see log and you don't see a base, it is the common logarithm, and we assume base 10. Say it again, BAP. The base is 10. The power is 1. And the answer, well, is very mysterious. 10 to the 1, of course, is 10. We're looking for 2 answers. When you're looking for multiple answers, we have this habit, it's a good habit, to get a 0 on one side. We move that 10 to the other side with subtraction. We solve by factoring. The signs are going to be different. The big one will be positive. The factors of 10 that subtract to make 3, that's positive 5 and negative 2. Set your factors equal to 0 and solve. But wait, do the answers keep the argument positive? If an answer makes either argument negative, you've got to put that in the trash. Negative 5 is not in the domain, but that answer 2 would keep this argument positive. Answer 2 would keep that argument positive. So 2's a keeper, and we're done.